Okay, so 21.2, so example 2, we're going to focus on what are solutions and then what are not solutions. Before we do that, real quick, remember that with a line on a graph, so if our graph looked something like this, let's say this line, let's back this up, let's say this line looks something like this. So we know it has positive slope, and let's say it crosses here at 1. So let's call this line, this is x, y equals x plus 1. And where are the solutions? Where are the numbers that will make this true? Well, the answer is all these points along the line, right? All of these points that follow the up 1 over 1 slope, when it starts at 1 and it follows the line, those are all solutions. So the solutions are on the line. So we know that like over here, these things, I don't know, way over here, that's not a solution to this because it won't give you the right x and y when you plug it in. And over here is not a solution, over here is not a solution. So the solutions are on the line. Now, what's a little different is when it comes to inequalities. So here are 4 inequalities. There's only 2, but I promise you there's 4. And we're actually only going to look at 2 of these. But you can see 2, but look, I told you, there's 4. Don't worry. Okay, so we're going to find some pairs that represent solutions to the inequality. And we're going to find some pairs that do not represent solutions. And then we're going to look at both sets of points. All right, so here's what we're going to do. We're going to use a black circle. So we're going to use a black circle equals a solution, and then a red X is going to be not a solution. Okay, so let's just start by finding some solutions. So let's look over here at the first graph. Let's look over here at X. Think about what this inequality symbol means before I say it. Think about it. X greater than or equal to Y. So let's go find all the points that we can. We'll just find a few. Where is X greater than or equal to Y? Okay, the easiest place to start is along one of your axes here. And I like to usually start along the x-axis. So let's go find some points that are solutions. So let's think about it. All along, let's pick this point right here. 2, 0. The x value is 2, the y value is 0. 2 is greater than or equal to 0, absolutely. What about this here? 4, x value is 4, y value is 0. 4 is greater than or equal to 0, perfect. 6 would be the same thing, 8 would be the same thing. What about 0? What about 0, 0? Is 0 greater than or equal to 0? Absolutely, it's equal to. Now let's go find some that are not solutions, because this is an easy line to work along. Let's think about this point right here. -2 in the x and 0 in the y. So is -2 greater than or equal to 0? Absolutely not, right? Negatives can't be bigger than 0. So what about the point -4 comma 0? No way. Negatives can't be bigger, and none of these, and none of these. Okay, now let's jump to the other easy axis here. Let's jump to where somewhere like up here. So the x value is 0 and the y value is 8. Is 0 greater than or equal to 8? Absolutely not. No way. Is 0 greater than or equal to 6? No. Greater than 4? No. Greater than 2? No. Let's drop down here. Let's look at maybe something like right there. The x value is 0 and the y value is -2. Is 0 bigger than -2? Absolutely. Is 0 bigger than -4, -6, -8? Of course. So let's just find a couple things to fill in, and then hopefully we kind of see a pattern here. Let's pick something just in this general area. Like let's go to this point. So it's 5, -5. So the x value is 5 and the y value is -5. Is 5 greater than or equal to -5? Absolutely. So we're going to put a point right here. That's a solution. Let's go jump in this area up here. let's pick, I don't know, this point right here. So we have negative 8 comma 5. So this is negative 8 comma 5. Is the x value of negative 8 greater than or equal to 5? No way, right? Negatives can't be greater than a positive number like 5. So this here is going to get an x. And hopefully maybe what we see is that, some of these points, these aren't going to work. And maybe points like down here, when your x value is positive, it's always going to be bigger than a negative y. So hopefully there's kind of a pattern that we can see. Okay, let's jump over to this one. This is the second one we're going to do. Again, I think it's good to start with a strategy along the axis. So we need x plus y to be greater than 10. Remember, this is strictly greater than. All right, so let's pick a point, easy point, like 0, 0. X is 0, y is 0. Is 0 plus 0 bigger than 10? No way. Is negative 2 plus 0 bigger than 10? No. No, we're going so far away. No way. What about 2, 0? Is 2 bigger than 10? No. Is 4 plus 0, 6 plus 0? No. Okay, so now it seems like we have different areas where there are going to be solutions. So let's go try to find some solutions here. And what I'm hoping you guys are thinking is that nothing down here should be a solution. And think about why not. Well, all the x values are negative, and down in this region, all the y values are negative. So how could a negative plus a negative ever be bigger than 10? No way. So nothing down there. So we could put a big string of x's down in here. All these are going to be no way. So where do we think that there are solutions? Well, again, we need x values that are something and y values that are something that will add to give us something bigger than 10. So we need positive numbers, really. So let's try them where they're both positive. So let's make x6 and y6. 6 plus 6 greater than 10. Let's make x8 and y8. 8 plus 8 is something bigger than 10, right? Let's make x4 and y7. 4 plus 7 is 11. That's bigger than 10. But then if let's say we don't make the numbers high enough, let's pick x to be 2 and y to be 5. 2 plus 5 is only 7. And if x is 4 and y is 4, 4 plus 4 is only 8. So again, hopefully what we're seeing is that there's some sort of pattern here. And maybe, just maybe, if we're thinking about lines, just maybe there might be some split where it splits solutions and not. And there might be some split where it splits all the non-solutions and all the solutions that are up here, or in this case, down here. So all we want to think about is, can we maybe see a pattern when we plot these points about which ones are solutions? And we're hoping to bring back this idea that there may be some line that separates where the solutions exist and where the non-solutions exist.